Well, first of all, thank you again, Sarah, for the wonderful introduction, and congratulations again to this year's award winners. It's a fantastic achievement. I would add one final thanks to Sarah for pointing out that the title does have a pun in it, which I will repeat later, but I was worried people up front might not realize it, so we will get to that. This next exploration of numbers in different languages and cultures will take us thousands of miles westward to South America. It will also invite us to consider a distinctly three-dimensional way of recording information. The name for this as of yet undeciphered recording device, which will be the subject of my talk today, is the Khipu, a knotted string register that fulfilled the functions of writing during the Inca Empire between 1400 and 1532 AD. Indeed, the Incas, whose territories at their height stretched some 4,000 kilometers along the spine of the Andes Mountains, from Ecuador and Colombia in the north to Chile, Bolivia, and parts of Argentina in the south, relied on quipus for the administration of a population often estimated at greater than 10 million from Cusco, their capital, which is marked in red on the map. A class of cord keepers called Khipu Kamayaks maintained accounts of relative information for the exercise of Inca power, rendering the empire, by all measures, the largest civilization of the pre-Columbian Americas. However, among my goals here will be to demonstrate that this is not the whole story, to dispel some common misconceptions about when quipus were used, what they looked like, and what type of information they recorded. This will go hand in hand with an assessment of where we stand with regard to our understanding of their mathematical properties. So, after introducing you to the structure of a quipu, I will divide the remainder of the talk into two parts. The first focusing on mathematical aspects of what I will term archaeological quipus, by which I mean quipus for which we possess detailed provenience, or information about their locations and contexts of discovery. In contrast, the second set of case studies will focus on what I call decontextualized quipus, examples often found in museums and private collections around the world that lack this same information. Finally, I'll conclude with some reflections on the path forward in quipu decipherment, focusing on a set of questions facing those who seek to better understand Andean mathematical practices. So first on chronology. For how often quipus are associated with the Incas, it may come as a surprise that quipus were not an Inca invention. The earlier Wari polity of the south-central Andes produced the earliest quipus currently recognized by the broader academic community, leveraging them for their own internal administration. Quipu use would also continue following the Spanish conquest of the Incas from 1532 onward, as various colonial actors queried Andean cord keepers to obtain demographic and other information soon after their arrival. Cord keeping would persist for centuries more, in fact, yielding a current estimate of about 1,000 years, or roughly from 950 to 1950 AD, for the minimum period of active quipu use in the Andes. For the purposes of this talk, suffice it to say that while quipu use reached its apex during Inca times, this represents less than 15% of its suspected functional lifespan. Given the significant variation in quipus during this interval, here I will only focus on a specific subset of the many quipu traditions, which I will describe using the synonymous terms canonical and Inca-style quipu. Canonical because quipus of the general structure shown in the diagram on the screen have become the prototypical image of a quipu in the popular imagination. And Inca-style because many quipus with this structure have been radiocarbon dated to the Inca period. An Inca-style quipu consists of a thick horizontal primary cord from which hang between 1 and over 1,000 thinner pendant cords. Vertical top cords may emanate in a direction opposite to the pendant cords, sometimes recording the sum of the numbers knotted in the associated hanging pendants. Both pendant and top cords can also have attached subsidiary cords, which sometimes have their own sub-subsidiary cords, and so on. However, only one element gives a quipu its name. It's knots. Khipu means knot in Quechua, which is a major Indian language. With these knots arranged in horizontal levels, like in this diagram, a quipu registered the number 1 with a so-called figure 8 knot, the values 2 through 9 with a so-called long knot of the corresponding number of turns, and place values of 10 or higher, which were tied closer to the top of the cord or the top of your screen, with simple overhand knots. As far as we know, the Incas lacked a unique sign for 0, other than to leave the corresponding cord or place value blank, that is, unknotted. Each hanging pendant cord commonly registered a single numerical value, which could allow us to think of the lower bound of an Inca-style quipu's contents as a collection of numbers. And yet, since the early 20th century, numerical knots are the only element of a quipu that can be reliably interpreted across most of the Inca-style examples. A Brooklyn-based historian of mathematics named Leland Locke Himself a collector of historical calculating instruments, deciphered the meaning of the 3 types of knots on the previous slide, publishing the result in 1912. In studying the dozens of quipus in the collections of the American Museum of Natural History in Manhattan, he uncovered one in which the top chord's numerical values equaled the sum of the values registered on the individual pendant chords through which each was interlaced. So in the example on the screen, the top chord that emanates upward would record the sum of the values knotted on each of the pendants that it is interlaced through. Locke has been likened by some Khipu researchers to Champollion of hieroglyphic fame for this same reason, though of course here, in our case, much remains to be deciphered. In the century of study since the work of Locke, and in keeping with the wordplay that gives this talk its title, it has become ever clearer that a quipu is not just numbers. We have identified variation in the spin and ply of each pendant chord, which refers to the direction in which the fibers are twisted and retwisted, with an axis oriented either like the backbone of a capital S or Z, in long knot directionality, with the backbone of each either Z or S oriented again, and in attachment knot direction, such that each pendant chord is attached to the horizontal primary chord in either a recto or verso fashion, among others. Further expanding this complexity is a quipu's colors, which are often many. The color chart displayed on this slide, for example, includes over 60 potential options for Inca-style chord colors, all of which can appear in various combinations and schemas. In my own research in museums, I've seen chords that are solid colors, some that change colors, and others, for example, arranged similar to a barber pole with 2 colors that alternate in a stacked fashion. Khipu users would have been able to convey meaning from running their hands along the chords, aided by the quipu's own internal spatial and tactile relationships, but exactly how they did so, unfortunately, remains unclear. Crucially, this is not to say that all these elements were in use at the same time on every quipu of this style, nor is it to suggest that these are all reliably data-bearing loci. Some variation between different quipus may ultimately be revealed to be idiosyncratic. But it will hopefully serve us as we now move to discuss quipus with particularly notable properties, which, given our current state of knowledge, has often taken the form of identifying particularly striking mathematical relationships. The first examples of these are to be found in what I have termed archaeological quipus. Now recall that archaeological quipus are here taken to mean those for which we have clear provenience. The picture on the screen, for example, shows a cache of quipus recovered from a deerskin pouch at Pachacamac, a pre-Hispanic coastal pilgrimage site south of Lima in 1976. These quipus have been posited as potentially recording information relevant to local ritual offerings, given the broader context of the site, Pachacamac, to which they pertain. Similarly, in the following 2 case studies, knowledge of the location of discovery has aided efforts in interpreting the meaning of the quipu's specific mathematical properties. But what subset of mathematical practice is reflected in each? 2 types will be discussed here. The first, called hierarchically ranked sums across quipus, or in my terms, vertical summation, as well the second being arithmetic relevant to accounting. So the first example. Just to the northeast of Lima, on the bank of the Rimac River, lies the archaeological site of Puruchuco, which is thought to have served as a center of local Inca administration. Some 60 years ago, a team excavating the site discovered an urn under the floor of a small building, which enclosed within it over 20 relatively well-preserved quipus of various sizes. 6 of these quipus have informed an analysis to the right, on the right side of the screen, and published most recently by Carrie Brzezin and Luis Felipe Villacorta, that demonstrates a type of vertical aggregation and partitioning that organizes the quipus into a 3-level hierarchy. The quipus grouped at each horizontal level of the hierarchy also demonstrate identical or closely matching numerical values and color patterning, which may have served as a possible checks and balances mechanism. Now, what we seem to be seeing here is a manifestation of how information was transmitted within the Inca-era administrative hierarchy. In short, numerical values from local accounts, level 1, which is shown at the bottom of the right hand of the screen, would have been summed within level 2 quipus, the middle row, which themselves would have been synthesized in the higher ordered level 3 quipus that were transmitted regionally, and that is potentially outside of Puruchuco itself. Certain knots toward the left-hand sides of the level 2 and level 3 quipus on this diagram have even been described as possible non-numerical place identifiers for the word Puruchuco, which may have allowed for the identification of the quipus with this location. Now, as for the more specific conditions of the use of these quipus, Carol Mackey hypothesized in her study of the cache that the chords belonged to a quipu master who lived near the main palace at the site. If so, such an individual in all likelihood would have interfaced with higher-ranking Inca overseers, a conclusion that the study of other archives of Inca quipus will allow for us to evaluate further. The second example takes us further south along the Peruvian coast to the Cañete Valley. It is here that we find the site of Inca Huasi, which, per the Spanish chroniclers, is said to have been a staging area for Inca military campaigns. Its associated storehouse facilities have also been the source of dozens of the most recently excavated archaeological quipus. Specifically, in the 2013 to 2014 field season, the Peruvian archaeologist Alejandro Chu recovered a total of 34 quipus from the storage area designated Sector A. These have been hypothesized to be records of the receipt and storage of goods arriving at the site, an interpretation supported by the context of their discovery. Several of the excavated quipus were found in direct association with food crops, including chili peppers, black beans, and peanuts. I will focus briefly on two of these quipus, numbered 267A and 267B, a picture of which is in the upper right corner of the screen. In both of these quipus, the numerical excerpt only from quipu 267A is used here for reference in the enlarged image. A repeating sequence of apparently arithmetic operations is registered in 3 chord sequences of the form y minus n equals x, where n is the constant value 15. So, for example, we see in chords number 11, 12, and 13 in the enlarged image of quipu 267A, the sequence 206 minus 15 equals 191. In addition, 2 other quipus found in close proximity to the ones you see the picture of register many of the same numerical values, but instead using the inverted form y minus x equals n, with the fixed n recorded as a repeating result. Now, 2 phenomena seem to be at play. The first is the recording of arithmetic relevant to an Inca accounting context. There has been disagreement regarding what the fixed values of 15 mean, with proposals of everything from a tax on incoming products to support Inca Huasi's managing personnel to a fixed amount of seed set aside for planting. But in any case, these quipus hint at the types of numerical operations that would have been relevant to the maintenance of a storehouse facility like this one. The second property is that of the paired or matching quipus. The repetition of values in complementary arrangements, that is, the apparent recording of y minus n equals x on some quipus, but y minus x equals n on others, has been explored by John Clendaniel in his doctoral research as a physical manifestation of net credit and net debit calculations. And a new set of 23 quipus discovered in Sector B at Inca Huasi by Clendaniel and Chu in 2016, which sometimes record much larger numerical values, will hopefully be instructive in forming more specific statements about accounting practices at Inca Huasi going forward. Now, the second set of case studies I'll cover in this talk pertains to what I have termed decontextualized quipus, examples of quipus for which we lack specific information about provenience. Our ability to discuss these quipus is in large part thanks to the work of previous scholars who called for and implemented their large-scale cataloging in museums and private collections. A brief survey of these activities will help in contextualizing what comes next. In 1897, the German archaeologist Max Uhle, a foundational figure in the development of Peruvian archaeology, wrote in his report on a modern quipu used near Lake Titicaca that museums possessing quipus ought to publish them. We would then clearly see what details remain to be explained, Uhle suggested, such that further inquiries could be proceeded with accordingly. The ensuing decades would witness a moderate, albeit patchy, response to Uhle's call. Leland Locke, who was mentioned earlier, published a book in 1923 which included a preliminary inventory listing the locations of over 40 quipus in Peru, England, France, Germany, and the United States. Erland Nordenskjöld, a Swedish archaeologist, published 2 studies in 1925 claiming that repetitions of the number 7 in a small sample of quipus were proof of their magical nature, both as defenses against evil spirits and registers of the synodic orbits of Venus and Mercury. However, more serious investigations would also emerge. They would often yield photographs like this one taken by an Argentinian researcher in 1937 that are sometimes the last known images of individual specimens, which have since been lost or otherwise consigned to obscurity. However, to do justice to the large-scale cataloging of quipus will require paying homage to Marcia Asher and Robert Asher, she an Ithaca College mathematician and he a Cornell anthropologist, who throughout the 1970s and 1980s grew the known inventory of quipus in worldwide collections from just over 70 to about 400 examples. In the photographs on the screen, you can see them both holding one of the largest quipus ever found, originally discovered by a Chilean archaeologist named Percy Dalsberg in Chile's dry north. Now, the fruits of the Asher's labor in this regard would be 2 massive data books with chord-by-chord descriptions of over 200 quipus using the general form that's shown on the slide. Careful measurements were taken of everything from the quipus colors to the groupings of pendant chords to information about the lengths, numerical values, and subsidiaries of individual pendant strings. Each Khipu's entry was supplemented with observations about its notable mathematical properties, if any, and these mathematical relations, as the Ashers called them, will be revisited in due course. Without a doubt, the move toward the digital cataloging of Khipus in the ensuing decades has drawn inspiration from the Ashers' persistence. Other Khipu researchers, myself included, have recorded data later incorporated into various database projects hosted in both Peru and the United States. The largest database, which was designed and implemented by Carrie Brzezin, an American mathematician and weaver, in 2002, is today maintained by the University of Chicago, at that university by the American archaeologist John Clendaniel. Of course, not all Khipus and museum storage depots are complete or mounted for public viewing. Detached or otherwise fragmentary cordage often accompanies a museum's Khipus, which, given its often tangled and fragile state, like in the examples here, sometimes precludes its cataloging and digitization. However, for hundreds of Khipus more, researchers have been able to log their locations. As part of a new book on the state of Khipu studies that has come out just last week, I've prepared a comprehensive survey of Khipu cataloging efforts over the last 100 years, which is summarized in this graph on the screen. The solid line here, and we'll see it repeat a couple of times, represents the aggregate number of Khipus inventoried in museums and private collections over the last century, while the dashed line, which appears closer to the present day, shows the number of those Khipus that have been digitized and entered into an existing database project. You'll notice the dashed line begins in 2002, coinciding with the creation of the first Khipu database. This effort has raised the known total of Khipus in global collections to at least 1,386, with 866 of these maintained digitally in an existing database. This new estimate represents a 50% increase in the global inventory of Khipus since the last attempt, published just a few years ago. These updated data can then serve as inputs to different types of visualizations, including this one, which is a dynamic map of historical Khipu cataloging efforts in Europe. And so as this cycles through, I would just encourage you to look at each one of the appearing blue columns there is showing you over time the discovery and then recording, cataloging, and publication of Khipus in museums throughout Europe. And I've done the same thing here for South America and for North America as well, but for the sake of time, we'll just look at Europe here. And as it plays one more time, you'll notice in just a few years here, the work of the Ashers pops up, and there goes Berlin. All of the other European museums, we have found, and I've come across them in dozens. And most of these, by the way, are, maybe not most, but many of these a researcher has not visited yet to catalog the Khipus. So this is really step one, to inventory the Khipus in the collection. And once the necessary funds arise, one of the researchers who works on Khipus will visit one of these places and record each Khipu's information, which is subsequently entered digitally and someday entered into a database project. Here is also a dynamic map of these cataloging efforts, a static map showing where we stand. So this includes the European collections as well as the North and South American ones that I had mentioned. With that, in the following 3 short case studies, I will survey some of the work that my predecessors and I have been conducting on decontextualized Khipus, including the identification of mathematical relationships, seemingly geometric information, and possible Rosetta Khipus, that is, Khipus that correspond to a surviving written source. The first of these, which you see on this slide, is what Marcia and Robert Asher called a Khipu's mathematical relations, which fill the pages of those large data books that they created in the 70s and 80s. Take for just one brief example, the following Khipus in the collections of the Berlin Ethnological Museum. I will focus here on the first 6 groups of this single Khipu, which are highlighted on the screen, each of which has 10 pendant chords. And so 10 pendant chords in each group times the 6th group yields 60 total pendant chords under consideration here. 3 properties are apparent in the highlighted area, as first noted by the Ashers. First, the 60 pendant chords consist of repetitions of only 4 numerical values, 11, 12, 20, and 21. Second, the sum of the 60 pendant chords, correcting for 1 missing pendant, is exactly 1,000. And third, when the pendants are added by their index, that is, pendant 1 in group 1 added to pendant 1 in group 2, added to pendant 1 in group 3, all the way through pendant 1 in group 6, each sum within a range of plus or minus 1 corresponds to a simple, or each sum, corresponds to a simple fractional part of 1,000. The list of those 10 fractions, each corresponding to 1 index in the 10 pendant-sized chord groups, is shown on the screen. The simplicity of the fractions in the Ashers' view can be plausibly interpreted as a trace of intentional decisions by Khipu makers. The Ashers would go on to identify even more complex properties. Toward the end of the 1981 book in which they reported their findings, the Ashers concluded that the body of arithmetic ideas used by the Incas included, quote, at a minimum, addition, division into equal parts, division into simple unequal fractional parts, division into proportional parts, multiplication of integers by integers, and multiplication of integers by fractions, end quote. The years to come will be important in evaluating the plausibility of each of these claims. Now, a second instance of mathematical properties that I will cover here is reported in the work of a Peruvian engineer and statistician named Hugo Pereira Sanchez. In 1996, Pereira analyzed 2 quipus, supposedly from Peru's southern coast, but deposited in the Berlin Museum in 1907. The Ashers had examined these 2 quipus in the 1970s and had numbered them 120 and 143. In their initial study of these 2 quipus, the Ashers noted 3 striking properties. The first being that in both quipus, each pendant chord in its first group on the left registers the sum of the corresponding chord index in several subsequent groups. That is, in these quipus, pendant 1 in group 1 is equal to the sum of the first pendants in groups 2, 3, 4, etc. Pendant 2 in group 1 is then equal to the sum of the second pendants in groups 2, 3, 4, etc. In quipu 120 specifically, the ratios of the associated values are consistent within about 1% of deviation. That is, chord 2 in group 2 divided by chord 2 in group 1 equals about 0.34. Chord 3 in group 2 divided by chord 3 in group 1 equals about 0.43, and so on. Finally, one pendant chord in quipu 143, recording the value 97,357, was posited to be the largest single value on any of the quipus the Ashers had studied. Now let's focus on quipu 120 for a moment. The numerical values for each of its 4 groups of chords are shown in the table, with each row written in the order of the chords in each group. That is, each row is one of the chord groups, and the order of the cells in each of that, going from left to right, represents the order of the chords. What Pereira noticed was that the constant ratios between pendant chords are not just limited to the pairs of groups the Ashers had identified, but in fact, the quotient of any 2 groups of chords in this quipu produces a constant ratio. Most strikingly, the correlation coefficient for any pair of chord groups in this quipu, that is, of any 2 rows of that table, is almost exactly 1. They produce a near-perfect linear relationship. Pereira even produced a geometric model in which the slopes of these regression lines could implicitly define the interior angles of similar right triangles, with the lengths of the legs defined by the values knotted on each pendant chord and the corresponding sum of the indexed pendant values. So what are we to think of this property? Were quipus used in the pre-Columbian or colonial Andes for the measurement of geometric or angular information? At least one other scholar of whom I am aware has suggested the possibility that quipus recorded proportional ratios relevant to building construction, but it has been the contention of my own research that we will ultimately need to analyze a larger sample to search for numerical properties on a grand scale. The third and final usage of numerical quipu information that I will discuss here is the possibility of finding correspondences between existing quipus and surviving written sources, raising the possibility of a so-called Rosetta quipu. In theory, most any Inca-style quipu might be a plausible candidate for correlation with a written source. Currently, written numerical records from after the conquest remain our clearest entry point to searching for exact correspondences. And in a subset of these documents, we even know the information to have been derived directly from one or more quipus. Such quipu transcriptions, or paper quipus as they're sometimes called, are among the most striking creations of intercultural encounter in the early colonial Americas. Recall that from the early years of the conquest, Spanish overseers elicited information from native Andean chord keepers in various settings. During the associated quipu readings, an Andean chord keeper would vocalize the contents of one or more quipus, an interpreter would translate the rendering in Quechua or Aymara to Spanish, and a scribe would record the result. The surviving quipu transcriptions, most of which pertain to the legal sphere, are often extremely complex. Perhaps the most famous examples registered as part of a 1560s proof of merit claim lodged by the Central Andean Huanca ethnic group enumerate over a decade of transfers to various Spanish visitors to their communities. These included everything from camelids to salt, fish, and maize beer called chicha. For many goods in the account, the Huanca chord keepers even distinguished between the goods that were delivered to the Spanish visitors and then those that were pillaged or stolen by them. Now, how such a binary distinction would or could have been noted in the original knotted accounts is unclear, though we might be tempted to speculate that this was indicated by some binary aspect of the quipus in question, like spin and ply or attachment knot, though of course other elements are possible. We are fortunate, thanks to the efforts of previous scholars to transcribe archival documents, to have access to published versions of many Khipu transcriptions, the largest of which being a corpus compiled by Marty Parsonen and Jukka Kiviharju. My recent research on this corpus has involved digitizing about 10,000 lines of Khipu transcriptions as originally penned and encoding the result in a machine-readable markup language called XML. In addition to enabling detailed linguistic studies of Khipu transcriptions, these digitized texts, like the digitized Khipus, allow us to visualize them in novel ways. For example, the map on this slide is the corollary to the maps of Khipu locations and museums and other collections that I have already shown earlier. In this case, we see the locations described in 72 Khipu transcriptions, grouped by the number of transcriptions per place. These represent a great variety of areas and climatic zones, which is in contrast to the overwhelmingly coastal concentration of Khipus with known origins. In addition, the numbers registered in Khipu transcriptions represent, as of today, the clearest point of intersection in the search for potential Khipu document matches, however defined. In this regard, I would highlight a fantastic analysis by Carrie Brzezin, who has used computational methods to compare the distributions of numerical values in extant Khipu samples to those of household-level census figures that were recorded following the conquest. Brzezin's analysis, some examples of which you can see on the screen, takes as its input several known census documents, each of which listing the number of members of each household surveyed in each location, and treats them as exemplars or templates for the identification of Khipus with similar collections of numbers. Subsequent statistical testing revealed a handful of Khipus whose numerical distributions are strikingly similar to those contained in the censuses, enabling their provisional classification as demographic Khipus. The analysis has even identified certain decontextualized Khipus as plausible registers of demographic decline in the decades following the Spanish conquest. Increasingly, it seems that to speak of a so-called time series Khipu may someday emerge as a realistic possibility. With that, I hope that this introductory survey has served as a crash course of sorts in the mathematical practices of users of Inca-style Khipus. We have taken account of various Khipu traditions, dispelling the myth of the Khipu as an Inca invention and considering its 1,000-year-plus lifespan of active use. A series of case studies have zoomed in on practices from summation and partitioning and arithmetic at Puruchuco and Incahuasi in the case of archaeological Khipus, to the more abstract multiplicative and even potentially geometric relations observed among decontextualized Khipus. Finally, we zoomed out to examine searches for potential Rosetta Khipus among almost 1,400 extant samples. So, where does this all leave us? By way of conclusion, I will introduce three questions that remain little treated in the field, but that might nonetheless serve Khipu decipherment efforts going forward. The first of these is, did Khipus record fractions, and if so, how? The Ashers claim not to have found evidence for fractional values represented on Khipus. However, early colonial transcriptions of Khipus sometimes note half units of various items reported by Andean informants. For example, 7 1/2 loads of quinoa. Now, assuming that the canonical base 10 knot system was in use in the corresponding Khipus, how might such quantities have been registered originally, if at all? Were halves or other non-integer values signed by specific knot arrangements, or were other elements of the Khipu used to distinguish them? A clear understanding of fractional values may help to reveal aspects of the decimal numerical knots that enabled more complexity than otherwise thought. The second of these questions is, what were the largest numbers recorded on Khipus? We cannot state with certainty even the largest order of magnitude recorded at the apex of pre-Hispanic Khipu use. Among extant samples, numbers as large as the hundreds of thousands have before been identified, which you'll notice is higher than the 97,000 number the Ashers had noted in their study in the 70s. These are quantities that fall in line with some of the largest groupings of people subject to the Inca's administrative structure, I would add. But we have to remember that Khipus recorded information about more than just people, including accounts of staple goods, for example, that were amassed in highly variable quantities. Frank Solomon has identified a quantity of over 1 million fish, which members of a central Andean village reported having given to their curate around the turn of the 17th century, for instance. Important work in this realm has been done by Sabina Hyland. She has proposed a decipherment of two types of color patterning on Khipus, with one pattern corresponding to individual level data and the other to aggregate figures. John Clendaniel has since found Hyland's decipherment of color patterning to hold relatively well across hundreds of digitized examples, though these patterns will need to be assessed across different types of registered information. The third and final question is, what is the role of redundancy in Khipu recording? This question is the least well-formed of the three, but it is a profoundly important one, in my opinion, for understanding numerical Khipus going forward. In short, certain aspects of Inca-style Khipus have been shown to provide seemingly duplicative information. For example, I have before observed quipus in museums with colors arranged in bands. That is, 6 light brown pendant cords followed by 6 dark brown pendant cords, and so on. However, these same bands of cords are already set off from each other by spacing along the quipu's primary cord. In these cases, then, are the colors serving a purpose beyond mere visual embellishment? If not, should they be considered redundant design decisions? Are they recording entirely different categories of information? A firmer footing with regard to redundancy might allow us to assess the interdependency of various quipu signs, to move beyond interpreting a decontextualized quipu as a simple collection of elements, to instead reading it as a script with its own rules, with a grammar, as John Clendaniel has referred to it. The anthropologist Denise Arnold has before raised the possibility of Inca-style quipus as a, quote, mathematics incarnate. Arnold used the word primarily in its strict etymological sense, documenting correlations between a quipu's components and human anatomy. However, I think it provides an impressively succinct way for describing an even larger sphere of meaning-making in the Andes. For quipus were as much registers of numbers as they were dynamic accounts of the administrative and social environments in which those same numbers operated. As far as I see it, we would be justified in considering them, to repeat the subtitle of this talk, knotted instruments of mathematics and more. Thanks, and with that, I'll take any questions.
First question here, with respect, this is from Evan Binkley, with respect to decontextualize these partial quipus, is it still possible to gain accurate information, or is it necessary to have a quipu in its entirety in order to know what it's saying?
It's a good question, certainly. Decontextualized, and the way I've used it in the talk, is simply to refer to quipus that, for which we do not have detailed information or pictures, for example, of the moment it was discovered and its location. Certainly, some of the quipus from those archaeological contexts can also be fragmentary, right? So half of the pendants might have broken off in the hundreds of years that it has been underground or in the sand or wherever it is found. With those fragmentary quipus, it is difficult, to say the least. But I would say it depends in step with the amount of the quipu that remains. And so some of the mathematical relations that the Ashers had identified in their studies were found in quipus that were fragmentary, or in other cases in quipus that, while complete, only had maybe 10 or 15 pendant cords. And so I would like to think, and perhaps optimistically, I'm quite biased, that even fragmentary quipus represent a promising path forward. I would add, just as a final footnote there, that there's been debate in the field about whether we should even examine fragmentary quipus and whether there's a threshold, let's say, after which a quipu is too small or too fragmentary to study. Sometimes it's too tangled to untangle safely without it falling apart. But again, this is influenced by my own optimistic opinion that we do have a path forward with quipus that are not complete.
Okay, thank you. I really like this question. If you could talk to someone from the period, says Ken Edwards, who understood all about quipus, what one question, you get one question, what one question would you get them to answer?
Well, there is a genie in the bottle at the Museum of London. The one question I would ask a quipu user of the pre-Hispanic period is whether quipus were a conventionalized system. And I'll elaborate on that. I wouldn't for the Khipu Kamayak. They would presumably know what that question means. But for all of us here, that is a debate that has taken place over the last century, of which really represents the history of academic quipu studies, is whether when we look at a quipu, it was part of a larger conventionalized system of meaning making. That is, did it have, to use the word grammar that John Clendaniel used, certain sets of rules and limitations on the types of recording and the types of signs that could be placed on the same string. And if the answer to that question is yes, then our decipherment pathway, we have grounds to be very optimistic about it, in the same way that the Rosetta Stone unlocked the hieroglyphic mystery. And finding a quipu that matches a written document would in turn allow us to infer characteristics of many other quipus, and based on our supposition that they were part and parcel of the same system of signs. If in contrast, a quipu was not to be considered a conventionalized sign system, or only partially pockmarked, whatever you want to call it, and then our focus in our decipherment efforts will have to be constrained by various aspects of Andean economic life and the Andean world. So I would just add there, to finish this answer, that in the Inca-Wasi context, Clendaniel's doctoral research has revealed aspects of those quipus, for example, in their color patterning, that is actually correlated with the arithmetic operations that happens within it. And so as he writes in his thesis, the first chord, if you might recall, corresponded to addition in the 3-chord sequences. The second one was subtraction. And then the final one was the result. The colors on those 3-chord sequences were quite striking because the first chord was a light color, the second chord was a dark color, and the third chord, registering the result, was actually a mixture of the previous 2 shades of colors. So we have a striking instance of correlation between colors and certain actions that a quipu was presumably registering, but it will only take time and effort to see whether such correlations hold true when we look at larger samples of quipus in the corpus.
I want to ask, what are they made of? Like, what are their ropes actually made of? Because...
You're right, and it's something I should have stated right up front. The majority of Inca-style quipus, so recall, those are the quipus that look like the diagram I showed you, that have the horizontal cord and then many that hang down from it. The vast majority that survive today are made of cotton. We also have examples of quipus made from vegetal fibers, so everything from certain types of grasses to parts of, forgetting the name right now, but for vegetal fibers, we also have examples of individual pendants that are made of human hair. And so the basket of raw materials that was used by a Khipu Kamayak in forming their collection of quipus, we have not settled on its boundaries. We have not set the goalposts, so to speak, for what materials a Khipu Kamayak would reach to in any given moment and for the creation of quipus, but we can say that the vast majority are made of cotton, but we also have examples of vegetal fiber, and I should also add of animal fiber as well. And since we have a good number, not many, but quipus strings that are made of the hair of llamas and alpacas and other camelids native to the Andes. The very last thing I'd add to this answer is that this statement, all these statements I've just made are of course should be circumscribed by the context of archaeological preservation, right? So since the vast majority of quipus pertain to the coastal regions, because the Atacama Desert is the driest desert on Earth, we do not know with certainty what quipus in the highlands, that is, for example, in Cusco, the Inca capital, were necessarily made of. We can only suspect, since camelids are often herded at higher altitudes, that many more quipus in the highlands would have been made of animal fibers, or at least would have had a sort of pot of resources of raw fiber from camelids to be able to put into them. But it just means that we have to put sort of an asterisk on any answer to the question of what quipus were made of. We can certainly point to the ones that we have today with us, but we wish there were more.
All the examples you've given of the interpretation of the knots and their positions, you've used binary notation. Is there any evidence that the quipus in other number bases, like octal or 12 or 16 or whatever?
It's a difficult question, whether we know of quipus that were registering numerical values in other bases, and besides the base 10 system that is most famously associated with the Incas, but again, I call Inca style. The short answer is we suspect that other bases might have sometimes been in play. The example I would point to is the Wari polity, which you might remember on the graph, the sort of 3D arrow that shows the different traditions of quipus. The one to the furthest to the left, the Wari, which are today recognized by the academic community as producing the earliest recognized quipus, at least. And I only say that because there's some debate as to whether a several thousand-year-old knotted object from the site of Caral constitutes a quipu. But putting that to the side, Wari quipus look different than the ones I've shown you, and I really didn't go into depth about them, but researchers early on in the history of those quipus have posited that Wari quipus used a mixture of base 2, 5, and 10 systems on the same quipu. I would add, though, that in recent years, work by Jeffrey Splitstocer, who's the world's foremost expert on these, has pushed against that hypothesis. And his view, at least as of his most recent writings, is that Wari quipus also utilized a base 10 system, but potentially with a stronger binary component, where knots, unlike in Inca quipus, could potentially have been used in Wari quipus to record binary on-off type distinctions as well.
Yeah, thanks a lot. It was really very thought-provoking. I have many questions, but I'm going to limit myself to one. Could you say a bit more about the dynamical making of a Khipu? For instance, you have a main chord. Do we have examples of main chords being extended? Or is it only one single chord to which pendants are added? Because depending on the answer to this question, the notion of fragmentary Khipu changes. Perhaps a fragmentary Khipu is a Khipu to which other Khipus might be added by extension. So could you say a bit more about the dynamical making of these things?
Of course. In terms of the dynamics of making a Khipu, I should say our first source whenever we have a question about how potentially Khipus were used or made is we go to the writings of the colonial chroniclers. So these are often Spanish, sometimes mestizo writers who were writing their works in the first, from the first decades following the conquest. And unfortunately, they do not give us any universal rules for how a Khipu was made, or at least at its moment of making. So we have to look to the field of archaeology. Once we begin to look at archaeological Khipus, and I would add at Khipus in museums and collections, which sometimes are decontextualized, what we find is a wide variety of construction patterns, of morphologies. So, for example, in museums, we have found Khipus where more than one primary chord is actually tied together or sometimes interlaced. And can we call that two Khipus? Can we call it one that was updated? Are they two parallel accounts of similar information? And we can't say with certainty. Other times, we have found Khipus where the pendant chords are entirely blank, that is unknotted. Presumably, and one can only hypothesize that Khipu is not just recording the number 0 37 times if there are 37 pendant chords on it, but since there's not a unique sign for 0, that is, there's no knot in the canonical system that means 0, just the absence of a knot, we are just left to hypothesize that blank Khipu might be like a blank Excel spreadsheet before the user has inputted information into it. The final thing I would add here is Frank Solomon is, to my knowledge, one of the strongest proponents of the idea of a Khipu as a mutable collection of things, or a mutable collection of elements. Solomon has, in his work, in his ethnographic field work, in a central Andean village called Tupicocha, where Khipus are still used in an annual civic plenum, that is, the incoming officers who are elected to lead the various descendant groups of the community. Khipu was draped over their shoulder once a year for the new incoming class, so to speak. In his work there, he has posited the hypothesis that no, we should not, when we look at a Khipu in a museum, think of it as a static register. We should not necessarily think of it as a final account that was then placed in a jar somewhere to be kept for time indeterminate, but that many Khipus would have been continually updated throughout their active lifespan. And unfortunately, absent a few examples of where we can see kinks in a cord for knots that presumably were unknotted, which one scholar has called ghost knots, which I think is a lovely term. I can't tell you for certain. If we're in a museum and we're looking at a Khipu where all the knots look like they conform to the canonical system, I would not be able to tell you by looking at it, at least not at our current stage, whether that Khipu had any of its knots updated, whether it is a final account we are looking at, or actually whether it was a work in progress that was stopped due to external conditions.
You've talked about some of the uses perhaps for accounting. Is there any implication or uses in the science of medicine? Yeah.
The chronicles do not give us good information about potential uses of Khipus with regard to medical practices during pre-Hispanic times. That has not stopped modern, I don't want to botch, scientists, I will use the more general term, from writing an article of potentially using a Khipu wrapped around an arm to measure malnutrition. But it is besides the point. Just to say then that the closest sphere, perhaps I would say, for which we suspect there were Khipus used is the field of ritual action. So we do have examples, and Sabina Hyland has written about this, that since the pandemic struck, and Peru has of course been one of the countries worst affected by the pandemic on Earth, so-called funerary Khipus, or a single cord with knots tied into it, that is tied around the waist of community members after they have passed away, that their usage has resurged during the pandemic. They're sort of intersect with Catholic with Catholicism in the Andes, but it is still at the level of a hypothesis to say that funerary quipus, in the strict sense in which we see them among living people today in Peru, were used during Inca, that is, pre-Hispanic times. I would also add that we do have examples of burials with quipus that are placed in direct association with the person who is buried. No one has yet written an article that surveys where exactly in relation to the body all of those quipus have been placed in the history of archaeological excavations. But suffice it to say for the moment, though, that the fact that many archaeological quipus were discovered in graves really had a grasp over the field for decades. If you had asked a Khipu researcher in the 80s, even the Ashers, where do archaeological quipus come from, they likely, and I don't want to speak for them, would have said that they all or most all come from graves. Today, with the example of Incahuasi that I spoke through about the formula y minus n equals x, we are beginning to find and are continuing to find many dozens of quipus in archaeological contexts that aren't necessarily mortuary. That storehouse, it has been suspected that those quipus recorded the receipt, right, and depositing of products for the storehouse's operation at that military staging site. So I would put all that together to say, while the chronicles do not tell us much about potential medical uses, we are certainly still at the point of hypothesis and hypothesis generation when it comes to the full range or genres, let's say, of quipus that were in use during pre-Hispanic times.
Thank Manuel Medrano again for a fantastic talk.